The creation. Need a William.
What?
Need a William.
William?
In your name.
Okay, let's go over similar triangles. We're going to do mostly section 7.3, and then there's a little again from 8.1 that we'll pull into this section. On 7.3, we're looking at similar figures, and if you look at the objectives, you'll notice angle, angle, side, 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 angle, side. What do you recall that we did with those abbreviations? Okay, we were looking at congruence. Congruent triangles had, well, we didn't have an angle-angle similarity. Why did we not?
Oh yeah, because the side lengths didn't necessarily have to be the same, even if the angles were.
You could have the angles the same, but then a bigger version or a smaller version of that same thing. In other words, similar triangles, but not always congruent triangles. So angle-angle similarity works, angle-angle congruence did not work. So we'll have angle-angle similarity. We have a side-side-side congruence, there is a side-side-side similarity. What's the difference going to be? In similar figures, what's the relationship with the sides? Okay, longer or shorter, so what are we setting up with the sides? Ratios, proportions. So the sides will be not congruent, but they will be in proportion. They will have ratios that are equal. Side angle side, where was the angle? In between the two sides. Same thing happens here. The angles have to be congruent, but the sides will be in proportion. So we have kind of the same things as what we had in congruence, but the big difference is the side relationship. The sides are in proportion. It's not that the sides are congruent. If you remember back which ones, what 5 did we have in congruence? We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Okay. The angle, side angle, and angle, angle, side, those both have 2 angles in them. That's what angle, angle covers. You don't even have to worry about side legs. Hypotenuse leg was a special relationship for the right triangles. The only way that that would work here is if you have one of those acute angles also. So we really don't have a hypotenuse leg for similarity. You need to know a little bit more about them. So angle-angle similarity, as far as your notes and your drawings to go with it. The wording on angle-angle similarity is if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. They will be the same shape, not necessarily the same size, but if you check the sides, they would be in proportion. 2 angles of one triangle are congruent to 2 angles of another triangle, and the triangles are similar. We don't need the third angle to be stated because what theorem would guarantee that those last angles are congruent? Third angles theorem is what we have, right? That applies to triangles. So although we could go angle, 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 just 2 of them is enough to come up with it. Okay, looks like you're done with the notes. So let's explain why the triangles are similar and write a similarity statement. So what about them similar? Okay, they both have right angles. Are right angles congruent?
Yes.
Support that? That was called the right angles congruence theorem, and it said exactly that. All right angles are congruent. So there's one pair of angles congruent. What else?
There's vertical angles.
Okay, vertical angles, and you'd have to do the 3 letters. So angle BCA congruent to angle DCE. And so now our 2 triangles are similar by angle-angle similarity. And writing a similarity statement means we have to do this type of thing. So a triangle ABC similar to D matched with A, B would match with E, and angle C with angle C. So you have to match it up in the right order. That's the similarity statement. You might notice that this kind of looks like a real short paragraph proof. Yes, basically that's what it is. So you are doing some thinking through, just like a proof. You'll have to write one a little bit later here. Okay, explain why these triangles are similar, write a similarity statement. Okay, don't shout it out. Do I need to have you work on marker board? Does that work better? No? Either on your paper or marker board. Explain why the triangles are similar. I don't know that this would be a good one to show me, but are they similar? I guess it's saying explain why they are. So it's implying that they are. Doesn't look like they are.
Boy.
I see
Yeah,
90
they are.
degrees and 90 degrees, but then I see 43 and 47. Those don't match.
Triangle sum theorem.
Okay, let's do the triangle sum theorem on each triangle.
Yeah, they match.
So angle C, when you subtract, triangle sum theorem, 180 minus
So A is
133 is 47? 47 degrees?
Yep.
And the missing angle here is 43. Okay, so we do have a 90, a 43, and a 47. So are they similar? Yes, by angle similarity. How do they match? So let's write our similarity statement. Triangle ABC is similar to triangle, what matches with angle A? D, and then E, and then so matching up the angles as we listed each triangle. So maybe it didn't match the way you were thinking it would. It's turning it instead of just folding it over. It's a little bit harder to match up similar triangles because of the different sizes. Okay, side, side, side similarity. Side, side, side similarity. I didn't think they showed enough in their picture, so I wrote the proportions in the hypothesis part there. So if three sides of one triangle are proportional to the three corresponding sides of another triangle, then the triangles are similar. So if we have AB over DE, which equals BC over EF, which equals AC over DF. If all those sides are in the same ratio, that means they're proportional. Conclusion, triangle ABC similar to triangle DEF. So to use this theorem, you'll have to do the ratios. And remember how we talked about shortest side compared to shortest side of the other figure, longest side compared to longest side. Do that type of thinking when you're setting up the ratios. You don't need any angles for that one. And then the third one was side angle side similarity. If two sides of one triangle are proportional to two sides of another triangle and their included angles are congruent, then the triangles are similar. That's what you know before you use that. Okay, so the hypothesis here, you have to know, like angle A and angle E are congruent. You also have to know below the space that was there, the sides, AB is proportional to DE, BC is proportional to EF. Those ratios are equal. At conclusion, you know those two triangles are similar. Same shape, proportional sizes. And again, when you're trying to figure out which sides to compare, out of the two that make up the angle, shorter side compared to shorter one of the other triangle, longer to longer. Okay, try some examples. Verify that these triangles are similar. How do you show, which is kind of an informal way of saying prove to me that those triangles are similar? Three possibilities, which one can you use here? Are you thinking side, side, side? Okay, you're gonna have to show me the ratios. So that you can prove to me that those ratios are all the same. So 2 would be in a ratio with the 3 of this other triangle. So base to base. And then the 3 would be compared to a 4.5, I don't care which one. It could be matching two different ways. Remember how we talked about reducing something like 3 over 4.5? Multiply by 10 to get rid of it, to get rid of the decimal. So then you're reducing 30 over 45. Okay, they are isosceles, so angle P and angle R are congruent. Angle S and angle U are congruent. Is there anything that would tell me angle P is congruent to S? That would be the part that here. If we knew that Q and T were congruent, then that would help. Okay, does 3 over 4.5 reduce to 2/3? Yes. Yes. Okay, so we've got 2/3, 2/3, 2/3. So they are similar because of side, side, side similarity. I like to use the similarity symbol rather than write out the word all the time. Yes?
So I was wondering, how do you figure out which one goes on top?
And it's actually your choice. Okay? If I choose to put 2 on the top, then the next fraction is going to have one of these numbers on the top. Okay? If you did it the other way, like if you chose to put 4.5 on the top, 4.5 over 3 twice, and 3 over 2, you would get 3 over 2 and 3 over 2 and 3 over 2 for the other pair. You'd still arrive at the fact that they are in proportion. Now the only time that that would make a difference is if I asked you what is the scale factor of triangle PQR to triangle STU, I'm telling you which order it has to be. So I would be telling you in that question that this needs to be on top. But if it's not saying a certain order, then it could be either way. Okay? All right. How about these triangles? Verify that they're similar. up being a side angle side similarity, not congruence. So this is why I told you earlier when we were on the congruence chapter that you needed to put side angle side congruence, because I knew there's something like side angle side similarity we'll be doing later. So don't just say side angle side. I don't know which side angle side you mean. So this one was, your angles are congruent, angle D and angle H. Then I checked DE compared to HJ, and DF compared to HK. They were both 2 to 1. Those were the sides that made angle D and angle H. So that was side angle side similarity. You would write this type of thing. So if you're going to have it be side angle side, be sure you are telling me about the angles. And you're telling me the sides ratios that are equal. Okay, how about this one? Verify that triangle TXU is similar to triangle BXW. Paired you up. Why don't you discuss this one briefly with your partner, especially which way you would be setting up some ratios if you're doing that. So I was normally going first row, turn around and talk to the second row, third row to the fourth one. We kind of have a group of 3 in the back sometimes there. Nora and Gracie, I don't know if you can hear each other if you talk. Okay, just kind of see how the other person is comparing sides.
Yeah. And then you have the UX by WX. And then X and X by WX. And that's the side angle side. Four-thirds or three-fourths, all the way around.
Hearing a lot of side angle side. The angles were congruent because they're vertical. Okay, and which sides did you compare? 12 over 16 and 15 over 20. Because you're going shorter out of the 2 compared to the shorter out of the 2. And those ratios were either 3 to 4 or 4 to 3, depending which way you did it.
Since it says like triangle TXU, does that be first then?
It really doesn't have to be. Now, if you were writing a proof and trying to have someone follow it, it might be easier to be consistent and talk about that triangle first all the time, but I'm not going to do that with you on that. Okay. How about this diagram? The triangles are overlapping here.
See the 90 degrees theorem and 9 plus 3.
So it might help to draw them.
Is 12. Wait, 9. Oh, 9 and 12. So 9 over 12. They both have the same.
Okay, so they both got right angles. What else? Okay, angle A is the same angle in both triangles.
90
What would
degrees.
you support that with? How would you put that in a proof? Okay, that would be a reflexive situation. You could say angle A congruent to angle A, reflexive right? Okay, what else? Oh, are they similar?
Yeah.
Okay, we have angle-angle similarity going on. Okay, now this problem went on to ask you to find CD. So CD is that length.
Well,
So other sides that we know, the little triangle has a 9 and a 5. The big triangle has an X and 12. Notice you would have to add that together. So to find X, X would be compared to what side of the little triangle? 5. And 12 would be compared to 9. Since we already said they're similar, those ratios have to be equal. So cross multiply. 5 times 12 is 60. 9 times x. 6.6 repeating. So it might be good to put 6 2/3 instead of a repeating decimal. All right, so drawing the triangles separately maybe is a good idea to do that. All right. Let's see, look through all those. All right, work with your partner, and let's find the length of RT.
Okay, so just set up the
Okay, so
It's 15. Eight divided by that is 15.
you have 15, Chris?
Oh,
15.2.
yeah, that's.
You set it up like this.
I just checked the word. Oh, I
Let
see.
me write it down now.
Okay, she's making art. She's calling it art. So,
It'll be professional.
I did 10 over 20 plus 12. So I did 15. I did RS over RS plus ST.
okay, so you did
Find
10 over
art.
10 plus x
Definitely it's 15.
equals 8 over
We're
12.
great singers.
And you
It's
distributed.
5, so it's
It's a
15.
privilege of a
So her x is no different than what your x is. But when she says 15, when she adds her 10 back on 15 are your answers. 2 ways to do the same problem. Just
Well,
one
yeah. Good job.
What's the best? If you're not doing that, she's doing it like what he's doing. Okay, instead of calling just that little section S, we're calling that whole top side.
You weren't there last year.
I know that.
So what's right?
Okay, what's right? What's right is that RT is 15. Okay, the triangles, did you do the similar part, angle similarity again? Okay, the sides, was there something I didn't notice?
Those are just so funny.
Okay, the right answer is 15.
Yeah.
Did it.
Now we discussed, I was discussing with some groups here, there's 2 different ways to solve this problem, depends what you call x. Did most of you call RT x?
Yeah.
You call the whole thing you're looking for?
Yep.
Okay. Malia would like to mention that she didn't do the whole thing, she just made ST x.
So,
And
like,
so she did, this whole side was 10 plus x. So she did like 10 over 10 plus x equals 8 over 12. So when she did her cross multiplying, she had to distribute. When she solved, she got x to be 5. So her x was just 5, but when she added, she got 15 for the final answer. That is going to be entering into something we'll do later on. Okay, this one's an actual proof.
Yes.
Haven't done too many, but let's see if you can do this. I know you can.
You have a lighter?
You might not want to, but you're going to. Okay, so what would be the things? What are the things to do? I'll get you another one. Okay, so we do 2 column.
Yeah.
Okay, first line.
The given stuff.
Okay, let's get the given stuff.
The given
Write yourself an example. say angle EBA and angle DCA are right angles. Given. Okay, what else do you know about the triangles? We're trying to get them similar. Ooh, Lena, what?
Something about angle A.
Something about angle A.
Say reflexive too.
Oh yeah, reflexive, that's right.
Okay, so angle A, there's only one angle A up there. It's congruent to angle A. Reflexive property of congruence. Okay. Is it angle angle?
Yes.
Yes.
No, yes.
Have we said both angle pairs that are congruent?
Yep.
Have we said the pairs congruent?
No.
At line 2, we have one pair congruent, but we don't have a second pair congruent, but we can get there, right?
Right angles, congruence theorem.
So we need to say, and you can't just say B and C in this one because B has an angle on the left and the right up there. So you do have to go angle EBA is congruent to angle, you could just say C. I'm going to put DCA just like the directions had it named by 3 letters. What's our reason that they are actually congruent?
Right angle congruence.
Correct. Right angle congruence theorem. That's why I reminded you about that earlier in class. Now we can say they're similar. So triangle ABE is similar to triangle ACD because of
Side angle,
Similarity.
angle similarity.
Thing we just
Is that theorem or postulate? I don't remember. Angle similarity. Postulate, I think.
jump, shoot.
Okay, that's all there is to that proof. So I knew you could handle it.
We always have proofs like that.
Will you always have proofs like that?
No.
No, I mean, that's, out of this section, that's the easiest. The angles are the easiest. I'm not gonna get real difficult with the other ones. So most of the proofs will be an angle.
That will be true.
Okay, on your notes, I do have reflexive, symmetric, and transitive about similarity. We talked about reflexive. We did have a reflexive of congruence. We had a reflexive property of equality. There is also a reflexive property of similarity. So for instance, a triangle ABC is similar to itself. It's the same shape, and the sides would be in proportion. What would be the ratio of the sides? 1 to 1. Does that make sense? Reflexive would be true. So if you have 2 triangles, if you have the first one, triangle ABC, similar to the second one, triangle DEF, then would the triangle DEF be similar to triangle ABC? This doesn't really matter which one you think of first, they're still similar. Now, if you were thinking through transitive, you would need to be picturing or thinking 3 triangles. First one, same shape and proportional size with the second one, so a different size version. And then that second one is a different size version of a third one. Would the first one be just a different size version of the third one? Yes, it would be. So those do work with similarity also. We won't do a whole lot with that, but just to point out they are true properties of similarity also. And then we'll focus on right triangles for the end of what we're talking about. Done with the notes? Okay, so here are 2 right triangles. Explain why triangle KMJ is similar to triangle KJL. Now, the triangles kind of overlap a lot. My Might help if we pull the triangles apart. Triangle KMJ, that is this triangle, KMJ, and then KJL is a little bit bigger. This was J. Okay, we're supposed to get those two similar. Can you help me out with information? JC. Okay, this angle M and then this triangle, angle J. Notice that those angle J's really aren't the very same, so we'd have to name by 3 letters. One of them goes the whole way, one of them only goes part of the way. Okay, but those right angles will be congruent. Okay, this angle K is the same total angle K in both of these triangles. Angle-angle similarity. So the third angle, so this angle will automatically be congruent to that one. There's a third triangle in this picture, right?
Yes.
Okay, let's look at that triangle a little bit. Kind of tall, skinny. J, M, L. Okay, what angles do we have in that one?
90.
Right.
Okay, right angle at M. Do you have any angle of that triangle that's congruent to the ones we already looked at?
We went to L.
Yeah, isn't this angle L? I know my pictures don't look the same, but this angle L is the same in the skinny triangle or the big one. So this was the big one, wasn't it? Okay, that's the big one, and this is my little one, so that angle's the same. So those two angles the same as these two. Isn't the little one similar to the great big triangle? And angle J would be the same as the angle K. Unless these two would make the medium-sized triangle similar to the little one. We've got 3 triangles here that are same shape but different sizes. They're all similar. So if I were marking, let's see, this angle would be double. This one would be single. Pull the right things over there. All right, we're going to try that matching up again. Question before I get rid of that one? Okay, let's look at another picture, and I want you to do the matching. Okay. Okay, right there's where I wanted it. Okay, we've got the 3 triangles again. Notice the 3 triangles. I start with a big right triangle. At some point, you're probably going to try and do this when it's not a right triangle, and it doesn't work that way. Okay? When it's a right triangle, it works. And then you have that extra perpendicular altitude that goes to the hypotenuse. That's what makes your 3 similar triangles. Okay, so TAH, I have named the big triangle. I want you to name the other 2 in the right order that they match. Name the middle and the little one in the right order. Drawing the 3 triangles and marking the angles might be a good way to do it. Mark the angle A that is shared by the big triangle and the medium triangle. Mark the angle H that is shared by the big triangle and the little triangle. All the triangles are similar, so if you've got 2 angles marked, you can figure out what the third one should be marked when you compare pictures. If it helps, is that what you think you're getting at? What you might notice is when I put TAH, T for the big triangle was the right angle. So what's the right angle of the middle-sized triangle? D. How about the little triangle? D. So don't these two have to both start with D?
Oh, right.
Because that's the right angle of those two? Then I would need to have some more marked, I think. A is reflexive, and that's also part of the middle triangle. And the last one, what angle would match with that? So I think it goes DAT and DTH. If you had your blanks two switched around, that's fine. How many got it there before I showed you? Get it matched up? Okay, questions for those that I didn't give enough time? Okay. Here's the theorem. This part is 8.1.1. So if you flip to the 8.1 section, that's a little bit of what we're tying into this lesson. That was the same section that we talked about the geometric mean. Because there are some theorems that deal with this diagram and geometric mean setups. I'm going to actually skip the theorems, but talk about how you get the ideas done. If you'd like to look at those theorems, it might actually make some problems easier for you. So I'll leave the actual theorems optional to you. But this one you will need to know. There's two geometric mean theorems that are optional. Okay, this says your hypothesis is you have an altitude to the hypotenuse of a right triangle. So you've got to have this kind of a diagram. If it's not a right triangle with that extra altitude, you can't use the theorem. What's the theorem? Two triangles are similar to each other and to their original triangle. So you have three triangles that end up similar to each other. I want you to be able to match up the triangles, and then we're going to find some missing links. On the homework, I'm going to give you the first triangle so that it's a lot easier to check if you match it up with what I started. If I just let you match it up, it's kind of hard to check. All right, example? You ready? Okay, complete the similarity statement comparing the three triangles, and let's see, which way was I going to go? U, V, W is how I'm starting it. So what we just did, one more time. U, V, W. Can you get them matched up, right? After you've done a number of these, you probably can not have to separate them. You might be able to tell which way they go. I started with angle U. Is that the right angle? Is that the 90-degree angle? No, so don't start with the 90-degree angle. So I don't think you start with Z, no. Figure out which one you need to start with. Ready yet? Okay. Here's what I've got. UWZ is one of them. And then WVZ is the other. You got it right. All right, so what did you maybe do to mess up? Are you putting an angle as one mark and the other angle is 2 marks? You're not just putting one every place, are you? You gotta pair them up correctly. All right, do we need to do another one? Some say yes. We'll actually do that in relation to this picture probably. This is using the same diagram, maybe not just saying how they match up, but using them. Okay? So in this one, we're going to try and find the length of x. And now there's 3 triangles, right? I just need to pick which 2 are helpful. So for x, x is a side of which 2 triangles? Okay, the small one and the medium one. You don't need the great big one. Okay, so let's think about the medium-sized one and the small one. Okay, they both have a right angle. This one has 20 and x. That one has 5 and x. What other angle matches? This angle is going to match
The bottom. That one.
bottom. Yes. And then this angle will be that one. Yeah. How do I know that? Okay, because of going through those earlier ones. Okay, let me back up the screen. Okay, let me go to this one. And sketch the 3 triangles. Okay, when I'm getting this matched up, angle L of the big triangle is this one. That one is also in the little triangle as angle L. But in the medium-sized triangle, I don't have an angle L. So which one matches with it is this one. Now how do I know that? Let's draw the triangles. I think this is kind of confusing, this first one being drawn the way I did it. Okay, let's go big triangle is this way. Okay, big triangle has angle L down here. Small triangle has angle L. Right angle, M, M, and J. Angle K, let's put the double marking. So that is also in this triangle. But I don't have an angle K in that one, do I? Okay, so what I've got to figure out is this angle J, what matches? Well, every triangle has a 1, a 2, and a right angle in it. Okay, so the missing J should be marked 1. The missing J here should be marked 2. If I put those up here, isn't that the 1 there and the 2 there? That's the way they always match in these. Okay? That skinny one is going to match with that skinny one. This wider one with that wider one. And the right angles together. So after I've done enough of them, I guess, I was kind of picking out what's going to match just from memory. But if we need to, we're going to draw those triangles and mark the angles every time. Realize every triangle is going to have a single, a double, and a right angle. So when I was drawing these, when I was thinking through the next screen here, I knew that every triangle is going to have a single, a double, and a right angle. So the medium-sized one had the double, the single would be here. The skinny triangle, I already put the single there, so this has to be the double. Is that making sense? Again, this one would be the double, this would be the single. Double, single. You know, the reason I was doing that is to find x. Now I'm going to set up ratios. The x of this triangle would be compared to what side over there? Notice the two angles that connected. So the x and the 5, and then I'll do a different color. The 20 will match with the x. And I'm going to write it in a certain order. I'm going to put 20 over x equals x over 5. Just reverse from what I had talked through. Because I want to show you that, do you remember what these two spots were called? Those are the means. And when we were doing geometric mean, I said both numbers would be the same, unknown both places. The theorem clarifies that the x, the altitude, is a geometric mean. What's in the fraction or the proportion with it? These two are described as the two segments on the hypotenuse of the big triangle. So it's always set up that way. And you can either concentrate on setting it up by the theorem or just setting it up by the triangles that I'm talking through with you. Have I lost you? No? Okay, so x squared equals 100. X would be positive and negative 10. Can I use both those answers? No, the negative one doesn't make sense. So x is 10 centimeters. Similar triangles and just the proportions comparing. Okay, let's try a second one. Each of you will work on it. Let's put the variables in a different place. Okay, the x is on that outer side now. Out of the three triangles, which two is x a side of?
The large and the second largest.
Okay, so draw the great big one and draw the medium-sized one. I don't really care about the little one this time. Mark the right angles in each one. You decide which way works for you to turn it. If you need to turn them so they're sitting the same, or if you want to leave them turned the way they are in the picture. Put the right angles where they belong. For this one, it'd probably be good to mark this angle in each triangle. X is in each triangle. 16 on the medium-sized. On the big triangle, you got a 19. Because this hypotenuse of the big triangle is a total of 16 plus 3. So this is my big triangle, this is my medium triangle. The hypotenuse of the big one compared to the hypotenuse of the medium, x. That leg of the big triangle compared to the matching leg of the medium triangle. What's 19 times 16?
304.
304. Have to do the square root of that. Do we want positive and negative? Just positive. Typically, you don't want to go to decimal because it's not going to be the exact value. So reduce radical. 304 factored. 4 times how much? Okay, you've got a magic calculator back there. 2 times 252, 152, sorry. 2 times 76, 2 times 38,
That's a
2
lot of
times
twos.
19. Okay, pairing up. There's a pair of 2s, it comes out. There's another pair of 2s, it comes out. 19 doesn't have a partner, so it
Poor
can't
guy.
go out to play. 4 times the square root of 19. Okay, thumbs up or down? Okay, really?
This is making sense.
All right, I'm gonna test you then. Here's your test.
Oh, I just failed.
Oh, let's see, wait a second. What did I have on that one? I don't want to test you on that one. Let's go with, I want to find one of those. Okay, this one. Find X.
Let's check the right.
Find X. There's always something more to it, right? 3 times the square root of 10 is that side. Which triangles are you using?
Biggest is
Okay, X is a side of, well, it's on the big one and the medium one, not really on the little one, but the little one has 2 numbers on it.
Oh.
Okay, let's see. Well, let's just draw each triangle and see, maybe that'll tell us. What's the big triangle got? Let's mark that angle that way. Big triangle has X plus 6 and 3 times the square root of 10. Medium-sized triangle, right angle there, that same angle, X, and that's it. Little triangle, 6, 3 square roots of 10. I need to mark another angle to get that one to match. Let's go double in this corner. That's double here. That would be double here on the big one. That one fills in. Okay, now X is on that middle-sized triangle, but there's just nothing else there. I don't think that middle triangle is very helpful, is it? So can we do the top and the bottom one? If I use X plus 6, what would I compare it to in the little triangle? I need to mark this last angle maybe. Isn't that the hypotenuse up here? So hypotenuse here would be 3 times the square root of 10. Okay, now same 2 triangles, 3 square root of 10. Compared to, would be the 6, wouldn't it? Lost? Oh, yeah. Okay, would you agree that the middle triangle doesn't have much of anything to help us out? Okay, now how am I coming up with what I'm writing? This is the hypotenuse of this triangle. That would compare to the hypotenuse of the little triangle. Maybe I made this look too weird. Maybe we need to do a better job, Mrs. Frank. Then this leg would be compared to this leg. It's between the same two angles in each triangle. So it would be like, what, flipping it, turning it, flipping it? Do you want this drawn a different way? No? So I'm just making those ratios. Question?
Okay, so I did the Pythagorean theorem to find the other altitude.
Okay, she did the Pythagorean theorem and found this.
Square root of 126, so then it would be,
Then you could use the medium-sized triangle if you want. Yes.
would it 6 after
What's the final answer on this?
it was 9.
9? Yeah, x was 9.
So then would it be like 6 and that leg would be similar?
6 and which one? This one?
Yeah.
Yes. Because this would be double.
Yeah. And then wouldn't it all be similar to
This side would be similar to that one.
Okay. And then I got stuck after that somehow, but.
All right, should I keep going here to show?
Yeah.
Okay, are you understanding my setup?
Yeah.
All right, so when you multiply 3 square roots of 10 times 3 square roots of 10 is going to be 9 times the square root of 100, which is 9 times 10 or 90. The other direction, 6 times x plus 6 would be 6x plus 36. So subtract 36, 54, and divide by 6, 9. The problem you're going to be doing, and if you want to go to the very last problem on the homework, number 12, that's what we were just doing up here. It has multiple variables on one problem. I just gave you one problem, but it's got an x, a y, and a z in it. So look at one at a time. So do you want to look at that problem together? Yeah. Okay, those would be, when you do problem 2, it's the right triangles match up the 3 triangles. I want you to start the big one with RPQ and then match it up. On number 3, I want you to start the big one as BED and then match it up. That way it'll be a lot easier to check it. If you want to look at that number 12 together, we can do as much as we have time for. The last problem on the homework. Number 12. And Malia mentioned, could you do Pythagorean theorem to find something? Yes, you could, as long as you have a right triangle. So maybe that would have made what we did on the board there easier if we would have
Come
used
on.
Pythagorean theorem.
And then that book has the
I wouldn't count on them.
I know yours is
Okay, should we just see, can you do anything Pythagorean theorem?
wrong. You can find why.
You can find y doing Pythagorean theorem.
That's something.
Okay, so that would be a way to do y. Now on the x, to do x, I'm going to take out the y and the z so that we have less confusion. What 2 triangles are probably involved here? Probably the little one and the medium one. Okay? All right, so little triangle has x and 10. Medium triangle has 10 and 20. Let's mark something besides the right angle. This angle is not this one, but the one up here. So that angle matches that one, and the double will match up here. Getting the idea, every triangle has to have a single, a double, a right angle. So x would be matched with 10 of this triangle. I'm looking at the angles. And the 10 of the first triangle would be matched with 20. That one. Then the one that was on the screen. But then if I bring back the z and the y, we said Pythagorean theorem, you could find y. We just found a way to find x. How about z?
Can't you use the Pythagorean theorem with x and 10?
And
Yeah.
y, yep. X10 and z. Yep, you could do that. That give you enough ideas? Mention Pythagorean theorem, really can help a lot on that one. So the one up here was different because of what I gave you, I guess.
Easy peasy.